Hey guys, alright then, so let's get started. I hope this video finds you well. I hope you are healthy and well at home, guys. So this is a big transformation for me as well. Right now I'm going to try to show you our first lesson. So today guys, in this video we are going to be covering lesson 3.1 everyone. Alright. So as you see on the first page, there's a quick formula here. That's a definition of quadratic function. And today we are going to be learning how to find vertex, axis of symmetry, domain range, increasing functions, and so on. And also here we're gonna see how to graph given polynomials. But that's a official definition. I'm not gonna use this way. I'm going to use my way. And also here you can see how to find vertex function. That's a kind of formula way, but this is your just FYI. I'm not gonna use this. I'm gonna use my way. Okay, folks? So let's get started. Now today's lesson we're gonna learn how to find those everyone. Okay, we're going to have a polynomial, and as you see here, like those, and then we are going to find vertex, axis of symmetry, domain range, increasing and decreasing. That's all what we do today. But before we do those, we should be able to graph them. Easiest way to find them is on the graph. That's why we gotta graph them first. I wanna teach you how to graph first. And we're gonna cheat over here. Alright folks, we're gonna use technology. We're going to use Desmos website to graph everyone. Alright, and let's say I want to graph the first one everyone, 15. Alright, so in order to graph this, you can refer back here, but I don't want to go with this. I just would like to go to Desmos and just graph it. So let's go to Desmos website. Just put that Desmos, this website guys, and let's just type our function here. What was my function? F of x equals to x minus 4 close parentheses. You can open up this keyboard here, square minus 3 and minus 3. So that's what we got everyone, as you see here. Let me just make it smaller. So as you've seen, that's my graph. So this is look like, let's see which one. As you've seen, so this one should be this one, right? So 15 should be B everyone. And look, make sure you pause at this moment, and I want to try those other three graphs and to see they belong to which one, guys, right? To graph one more time, we just go to Desmos and graph it. That's all. So let me move on to my second part of my lesson. Let's say we have a function, polynomial function like this, and we gotta find those following: vertex, axis of symmetry, domain range, and so on. Okay folks, let me copy this. I'm going to need this a lot. Okay, here we go. Okay, first of all, how to find vertex. So vertex, this is how you find. So let me refer back to my first graph. Vertex means when we graph our polynomial, you're gonna see something like this or something like this. And as you see, those curving points are called my vertex point. So all what we do is just graph and see those top point or bottom point. That's all what we do. So let me go to my function first. So my function is this one. Let me graph this first. X squared minus 14x x squared minus 14x plus 48, I believe. Yes, okay, that's my function. So as you've seen, let me do this. Let me screenshot of it. Let me go this way. Here we are. Let me make it smaller a little bit. So as you've seen, so here, so which means like this bottom point should be my vertex point. If you just like come over it, you're gonna see it. So 7, -1. So that's my vertex. 7, -1. So it should be 7, -1. That's my vertex point. So second one is axis. So axis means axis of symmetry. Axis of symmetry. Like which line can make this graph symmetric? That's what I'm looking for. So as expected, if I have a line like something like this, right? If I go down like this, so like this line, I know it looks ugly, I'm sorry about that, but this line is gonna make it symmetric. So this line should be axis of symmetry. So as you're seeing, this line cross x-axis. So I'm gonna say x equals to this line cross x-axis at which point. So as if you get closer, you will see that it's going to be x equals 7, right? That's my axis. And domain, so domain should be, like we already talked about this before. Look at this graph. If you go like this, it's gonna cover all those x numbers. If you go like this, it's gonna go forever. It's gonna cover all those negative numbers as well. So domain is going to be all real numbers from -infinity to +infinity. So let me move on to next page. Like same question, we're gonna just keep answering the others. Let me copy paste this graph so I can use it. Here we are. So this time range was my y values, right? So like this graph covers which y values. So as you see, it's gonna start from here, it's gonna go all the way up, folks. And this point was -1. So we're going to start at -1, and it can go up all the way to infinity. Let me write here that this point was 7, -1 point. Okay, we are done with vertex, axis of symmetry, domain, range, and then determine largest open interval of domain over which is increasing. Oh, look, at which point this graph has been increasing? I gotta see that one, guys. So as you're seeing, starting here, this graph has been increasing. So we're gonna say that increasing. So we're gonna say we start at, like, I'm gonna look at, it says domain, right? Like we're looking for interval of domain. So I'm gonna look at my x value. So this x value was 7 here. So which means starting at 7 to infinity. This graph, it's going to be parentheses, 7 to infinity. And what about decreasing part? Decreasing. And that's the last one. Largest open interval over function is decreasing. So as you're seeing, like if you look at from here, my graph has been decreasing all the way down here, right? So it's coming from -infinity all the way up to 7. Okay, guys? So that's how we find those. Right? That's my first one. So yeah, we done this one already. So I would love to show you one more example, and then the rest is going to be on your own, guys. So you can, I would like to show you this one as well, and the others you can try on your own. Also this one you can try. Also I left here those examples, so as you see, you can see the answer key here, but make sure, guys, you just try, make sure you get those numbers. All right, but let me show you one more example. Let's say on this one, my first step to find those should be graphing again. let's graph this first. Let me just get rid of this. X squared minus 2x plus 3 plus 3. Okay, we graph it first. Let me just screenshot of this. Here we go. Let me put over here. So one more time, my vertex was like the curving point, the bottom point you see here. So it's going to be 1 and 2. So write them here. Vertex should be like 1 and 2. Also, we can see on the graph as well, like 1 goes to 2, folks. And then secondly, axis of symmetry. Axis of symmetry. So as you're seeing, as expected, so like if I have a line like this, so it's gonna make it symmetric. So it's going to be x equals 1 line. And domain should be, like as you see, it's gonna cover all those positive numbers. It's gonna cover all those x numbers. So it's going to be all real numbers from negative infinity to positive infinity. But range, there is a restriction on this one, right? Range was y. This graph will cover those y numbers as you've seen. So you start at 2 and going up forever, right? So, and lastly, increasing and decreasing part. Increasing and decreasing. So let me copy paste this one more time. Here we can see better. Here we go. So as you've seen, like starting here, this part should be my increasing part, right? So it should be like this point was 1. Okay, 1. So it should be started at 1 and we go all the way up to infinity. But if we check, let me check the blue. But on this side should be decreasing and decreasing as you're seeing up to 1. Start from negative infinity to 1. Alright folks, that's how we do those, but make sure you can try on this one by your own as a practice, and then also you can try those examples and you can see the answers over here. Have a good one everyone, and I hope to see you soon.